Hello everyone, welcome to our channel Biological Concepts. In today's video, we will solve some mathematical problem on absorbance and transmittance that is related to Lambert Beer Law. So stay tuned. So this is the cuvette where the sample solution is present, and through this sample solution a light is passed. This one is the incident light that is expressed as I0, and this one is the transmitted light which is expressed as I. And this is the path length, also the width of the cuvette. Now, to solve some mathematical problems that is related to absorbance and transmittance and also that is related to Lambert Beer Law, you have to know some formula. Okay, the first formula is absorbance A is equal to log 10 into I0 by I, where I0 is the incident light and I is the transmitted light. Next formula is T, that is transmitted, is equal to I by I0, why I0 is the transmitted light divided by the incident light. And the most important formula is the A is equal to epsilon into C into L. This is the Lambert Beer Law formula, where A is the absorbance, epsilon is the molar absorbance coefficient, L is the path length, and C is the concentration of the sample solution. Okay. Now, according to Beer's law, the absorbance is directly proportional to the concentration of the solution of the sample that is used in the experiment. That is, absorbance A is equal to C, that is, absorbance is equal proportional to concentration. And the Beer's law is absorbance is directly proportional to the length of the light path, which is equal to the width of the cuvette. That is, absorbance is proportional to the path length. Okay. Now, sometimes we have confused that in Beer's law, if the absorbance is directly proportional to the concentration or the path length, or in the Lambert's law, the absorbance is directly proportional to the concentration of the path length. Now, to solve this matter, you can remember like that. In Lambert's law, the first letter is L, and in Lambert's law, the absorbance is directly proportional to the L, that is the path length. So L and L. So in Lambert's law, absorbance must be directly proportional to the L, that is the path length, and the other one is the concentration. So Beer's law, in Beer's law, which is absorbance is directly proportional to the other one, that is the concentration. Or you can remember that's the Beer's law. B is the first letter and the B is followed by the C. So C is the means concentration. So in Beer's law, the absorbance is directly proportional to the concentration, and in Lambert's law, that is absorbance is directly proportional to the L for length, that is A proportional to the L. Okay. Now by combining these two, A proportional to the C into L, that is concentration to the length. Now when you omit this proportional sign and add the equal to sign, then constant is always required. Here the constant is epsilon, which is known as the molar absorption coefficient of that material, or it may be expressed, it may be also known as the molar extinction coefficient or molar absorptivity. And this molar absorption coefficient is expressed in terms of mole inverse, semi-inverse or liter mole inverse, semi-inverse. Okay. So these three formulas you must remember. Okay. These three formulas, that is A is equal to log 10 I0 by I, or transmitted is equal to transmitted light by incident light, and absorbance is equal to epsilon into Cl, where C is the concentration, L is the path length, and epsilon is the molar absorption coefficient. Okay. Now, the first problem is that a solution of thickness 1 centimeter, transmitted light is 0.5 times of incident light, and the molar absorptivity is 0.25 mole inverse semi-inverse. Calculate the concentration of the solution and the absorbance. Okay. So you have to calculate the concentration and the absorbance. Here the thickness of the solution mentioned is 1 centimeter and transmitted light is 5 times the incident light. So the incident light and transmitted light is mentioned here. Also the molar absorbtivity is also mentioned here. So first of all, we will calculate the absorbance. As you know that absorbance is equal to log I0 by I, where I0 is the intensity of incident light and I is the intensity of the transmitted light. Here it is mentioned that the transmitted light is 0.5 times of the incident light. So if the incident light is 1, then the transmitted light would be 0.5. Okay. By putting this value A is equal to 0.301. So the absorbance will be 0.301. Okay. Now we have to calculate the concentration. We get this absorbance value. Also here the thickness of the sample solution is mentioned, and molar absorbability also the mentioned. So A absorbance is equal to epsilon into L into C, where L is the path length, C is the concentration. By putting this value, C is equal to A by epsilon into L, and the answer will be 1.204 mole. Okay. Next question is, a solution in a 0.05 semi-length cuvette has an absorbance 0.85 at 360 nanometer. The absorbance coefficient of the solution is 5.2 into 10 to the power 3 liter mole inverse semi-inverse. What is the concentration of the solution? So, here the length L, absorbance A, molar absorption coefficient epsilon is also mentioned. So, we have to calculate the concentration of the solution C. Okay. The A is equal to epsilon into C into L. So, we have to calculate this C. Here the absorbance is 0.85 and molar absorption coefficient epsilon is equal to 5.2 into 10 to the power 3 and the path length here is 0.05. By putting this value, the concentration is equal to 3.326 into 10 to the power minus 3 mole. Okay. So if you like this video, please like, share and subscribe to this channel. Thank you.